I'm going to start out. It seems like we have a majority of the questions are for Chris. Chris, several questions kind of talk about the different modeling that you did in design for eliminating joints through peer integration. Did you consider any strain gauging or any kind of research that you might do to kind of verify what you looked at, what you got in design, that you actually got in construction and afterwards?
We didn't with that project, but that would be definitely an interesting project. I know we partner with our local universities a lot, so that is something that we could look at with this example in the future.
Another one goes to something that really kind of ties back into what we saw from Virginia and New York. The question says, I'm understanding correctly that the negative moment area over the piers, you said you only needed about 1 meter, roughly 3 feet here in US terms, on either side of that pier. That seems short. Have you seen anything that in the experience of the inspection of that shows that that isn't performing?
No, actually, it's been in the field now for over 2 years, and I know I've been back a number of times, and it's performing great.
Question I think is for Jason. Are you aware of any states that use Pervious cellular backfill behind their abutments to help with that drainage issue?
I don't remember if we identified any states that use that in the scan.
Did you find any states that have maybe kind of changed their design standard? This question comes to you about, did you find many states using pilings below their approach slab vents and approach abutments and approach pile caps because they are more flexible versus the abutments? Did you see any of that?
We did not see anyone using piling underneath their approach slabs.
Both, I guess, kind of maybe New York and Virginia could talk to this, and actually Jason or Earl could as well. Are any of the states using a floating span system? By floating, I'm referring to a superstructure resting on elastomeric bearing pads with no longitudinal fixity. The pads carry all the longitudinal forces, and typically these floating spans are pre-stressed girders with a continuous deck. Why don't the states kind of chime in on that if anybody's using that in their designs?
This is Jim with New York State, and no, we do not do that.
This is Sounder from Virginia, and yeah, I agree. We don't do that either.
From California, likewise, that's not a structure type that we use.
For Jim, what factors, or it might actually be for Soundar too. I know they're using ECC. I'm not sure if they're using UHPC, but what factors determine the shape, size of that UHPC joint?
The main factor is, the bonded length, which is what's going to accommodate the girder end rotations.
Okay.
So that's a design parameter. And then outside of that, we like to anchor the link slab into the slab. That's more of a function of what the existing reinforcement is and where it's located, depending on what sort of joint system was there prior. You may have to go further into the deck just to get enough length on your longitudinal reinforcement to engage it. But it's mainly the girder rotation that's the predominant factor in determining the length.
Sounder, did you want to add anything to that, or?
No, I agree with Jim. We haven't had any rigid partial depth link slabs in Virginia yet. It's still under research phase. We are planning to use fiber reinforced concrete developed in-house in place of UHPC for a variety of reasons. We think the length, the width of this joint will be different from what New York is using because of the strength of concrete.
Chris, this question comes to us. Did you have to strengthen the substructure at all to accommodate the additional loads?
With this bridge, we didn't. The substructures were quite beefy, luckily. We did do an analysis of the footings to see when you have that additional rotation. You have the thermal null point at the center of the bridge, and all your piers are trying to flex out from there. There was a bit of stress on the edges of the footings, but we were okay.
Did the bridge in Nova Scotia include an analysis of the deck ponding or the water on the deck in terms of, is all the water going off the bridge now, or do you have internal, like how's the drainage on that deck?
Fortunately, with this bridge, we do have a bit of a vertical slope for drainage, so we were okay there as well. Yeah, we're not seeing any ponding.
You broke up a little bit on that response. Are you saying that you had enough road slope that it carried it right off?
There's enough slope, and we also reinstated some of the drains as well to make sure that we intercepted some of it. Like, you didn't have the full 83 meters trying to drain to one abutment. We intercepted some of it part way.
For the hydro demolition, especially up on the bridge rail, did you have any issues with controlling the removal depth?
No, we didn't have any issues with that. I know they adjusted the pressure and they did some trial and error at first to get it down, and then they ran with it. But yeah, we didn't have too many issues with controlling depth. The only issue we had, I guess, was with protecting traffic, because the traffic was 6 feet away on the other side of that jet. We were shooting the jet horizontally against the barrier. We had to have a pretty strong steel shroud around it.
Jim, at the abutment, when you have longer or heavily skewed bridges in New York, what do you do? Do you just not build the link slabs, or is there a limitation on that?
I'm sorry, you said at the abutments?
Yes, at the abutment, for if you have, for longer span bridges or heavily skewed bridges.
We haven't put any link slabs at an abutment. Actually, I take that back. We have one job where we have done that, but it's not a common practice yet anyway. It's something that is of interest to me, and maybe we'll get some more out there. But we typically use what we call jointless details, where basically the superstructure slab will slide over the back wall, and then the approach slab moves, and then the movement's accommodated by a sleeper slab with a joint. Or I can add too that we do sometimes we'll do retrofits to a semi-integral, or cast a new back wall integral with the girders, and go that route.
I can add from my time at New Jersey DOT, we made the bridge seats semi-integral at times to help carry that movement as well. Well, actually, for all the states that are on, are you now designing bridges to be jointless? Is that kind of one of the standards? I think Virginia, I think Soundar, you did say that's a practice, and it's in your design manual. But what about New York and Michigan as well as California?
California, we are not deliberately eliminating joints by a design requirement. We still are providing joints at the abutments. We got to accommodate the movement, and so that's where we are now with that practice.
Michigan, we are doing everything we can to eliminate joints, retrofit and new bridges.
For New York, we don't have as strong a policy as Virginia. Yeah, we try to eliminate joints whenever we can, and our first abutment type preference is integral, and then semi-integral, in the spirit of not putting any joints on the bridge.
As Dick, as you said, yeah, we do not, we do design bridges without joints. In fact, one of those real long bridges in 2016, the bridge 1,900 feet long without any joints with Virginia abutments, and it's functioning well.
This is a great question. Have any of the jointless details for folks been utilized to eliminate a longitudinal joint? Either Virginia or New York, have you ever done that?
This is Jim with New York. We eliminate longitudinal joints all the time, but we don't necessarily replace them with any sort of special detail. We take the joint out, reconstruct the deck, and then we reconfigure the bearings to accommodate movements in the transverse direction as well as longitudinal in that case.
Same in Virginia. We don't typically have many longitudinal joint bridges, but it happens once in a while. So it's not common at all.
One quick question for Jason before we're done. Will yours be available? Because NCHRP doesn't like to release information until the report's finalized.
Yeah, we shouldn't put mine on there. It's still a draft presentation.
And do you know when they might be approximately publishing that?
I mean, before COVID, it was supposed to be August of this year. Some of the reviews got slowed down a little bit, and it's at the editors now. So once it's done at the editors, it needs to go for a approval vote, and then it'll be published. So I'm hoping still this fall.
You may have 2 documents available for those Christmas stocking stuffers at the holidays: the case study from FHWA and Jason's NCHRP panel report. Thanks so much to everybody for the people participating. We had over 400 at one point, and especially for our presenters. Everybody have a great day. Bye now.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.